Hello, everyone, and welcome to the February 2023 edition of the ASP.NET Community Stand-Up. Today with us, we have Daniel Roth.
Hi, everyone.
We have John Galloway.
Hey, I'm quite excited to be here, see all the crazy, exciting new demos.
Yeah. Javier Calvaro.
Hello, everyone.
And Steve Sanderson.
Hey, good to see you all.
So the topic for today is the Blazor unification effort, or as we've been calling it, Blazor United. But before we jump into that, first we have some community links to show. So we'll go ahead and share my screen for that. So first what we have is a Blazor component library called Blazor Bootstrap. And this wraps the very popular CSS framework Bootstrap, but provides a nice Blazor abstraction over it. So if you have a project and you intend on using Bootstrap heavily in it, consider this Blazor Bootstrap library. They just released a new version, 1.4.4, with improvements to their grid component. So if you're already using it, be sure to upgrade and check out the new version. Next, we have a pretty interesting Blazor component that I found called Editor Config Wizard. This is by Christopher Strube. And if you are creating an editor config for your project, and you don't want to type out the config manually, you can use this wizard to guide you through selecting your different style guidelines for your project. So it provides a very nice kind of visual representation of what each style guideline is that you can pick. So maybe I prefer this style, and you can just kind of go through the wizard, and then at the end it'll spit out an editor config for you. And so it's a lot easier than going through and typing out the file manually. So I thought that was pretty cool. And another reason this project is neat is because it provides a nice example for a wizard component. So if you need a component like this in your own project, you could use this as a reference. So
yeah, I thought this was really cool. I clicked through there and like you're saying, like it's hard to know what all those rules mean. So that was really nice, the setup there with the visual kind of implementation.
Yeah, definitely. Yeah, and it looks like this project is still in its early stages, but there are lots of goals here. So hopefully you see some more cool future things from this project. And next we have another cool component I found called Signature Pad. And so if you need signature functionality in your app, then this provides just a nice natural way to kind of draw out a signature. That's not my real signature, by the way, so can't steal it. But yeah, so if you need an app that requires some sort of signature and like a form submission of some kind, then check out this component.
Isn't it so funny that we still use signatures as a security feature these days? I just find that hilarious.
Yeah. And you have to fax it to somebody.
Yeah.
We had that's interesting because at .NET Conf, I believe they did we've done a Maui hybrid demo that included a signature, but I think it was not it wasn't as simple as a component, like it pulled in a JavaScript library and stuff. So, yeah, neat.
Yeah, definitely. And next, there is a new version of Blazorize. Blazorize is one of the third-party component vendors for Blazor. There are lots of those that you can choose from when using Blazor, but they just released a new version, Blazorize 1.2, with a lot of new features like a lot of animation components, in addition to improvements on their existing components. So if you're using Blazorize, check out the new version. If you're not, take a look at it as one of the options to consider when you're selecting a component library.
Tailwind integration, that's cool. Like yeah. I hear that's the thing now. Like interested to hear how many people are using Tailwind these days. I hear quite a few.
Yeah. Seems like the hot thing at the moment. So finally, we have a mapping library called GeoBlazor, and I hadn't heard of this before. Maybe some of you have, but it wraps the ArcGIS JavaScript library and provides some very thorough map functionality. So if you need maps in your project, definitely give this library a look. It has lots of features for like custom like vectors and like vector layers and things like that. Feature editing. Yeah, it's a very full featured map library. So definitely check this out if you need any kind of map in your project.
Oh yeah.
Yeah, you can do things like edit the map and things like that. It's pretty cool. I played around with it a little bit, but definitely check out GeoBlazor. Seems very full featured. And yeah, that about does it, I think, for all the community links.
Cool. Very nice.
So yeah. And Dan, I'll hand it off to you now.
Oh, all right. Let's do this. Yes. The main event. Let's get started. All right. So today we're going to take a little bit of a deeper look at one of our investments for .NET 8 that we are currently calling Blazor United. So what is Blazor United all about? Well, today in ASP.NET Core, we have a couple of different ways of building web UI. On the server, we have MVC and Razor pages that generate HTML in response to requests. This pattern is often called server-side rendering, and it's pretty common today. It's not just a pattern implemented by an MVC. It's used by a bunch of other frameworks too, PHP, Ruby on Rails, even ASP.NET Web Forms. These are all server-side rendering-based frameworks. And the nice thing about this pattern is that the rendering from the server helps apps to load really fast because all of the hard work of fetching the data and deciding how to display it has already been done on the server. The client just needs to display the already rendered HTML. The app can take advantage of the powerful server hardware and can directly access data and backend services as part of its rendering logic. Now, server-side rendering isn't great for richly interactive UI because typically that you have to send every UI interaction to the server for it to be handled. So for rich interactivity, what you really want is to render the UI from the client, which is often called client-side rendering or CSR. By rendering from the client, you can have really low latency UI interactions like drag and drop, and you can leverage client capabilities like local storage and access to things like the camera and other client platform features. For client-side rendering with .NET, we of course have Blazor. Blazor's component model is focused on handling UI interactions from the client. Now, a lot of modern web apps actually need a combination of these approaches, both server-side rendering and client-side rendering. Like maybe your homepage or your blog is best handled with server-side rendering so that it loads really, really fast and it can be easily indexed. While more elaborate functionality in your app that needs the responsiveness of running from the client, maybe you handle that with client-side rendering. Currently with .NET, if you want to do this, this requires using multiple different frameworks together. You use MVC or Razor pages together with Blazor to get the best of both those worlds, which you can absolutely do today. But in .NET 8, we're working to combine the benefits of server-side rendering and client-side rendering into a single consistent model based on Blazor. And we're currently calling that effort Blazor United. Name subject to change. We're not sure if that's going to be the final name that we ship with in .NET 8, but that's what we currently call the project. Blazor United will enable you to use a single Blazor-based architecture for all of your web UI scenarios. You'll be able to use Blazor components to render HTML directly from the server and also get full client-side interactivity with Blazor Server or Blazor WebAssembly. And that's all within like a single project with the ability to easily switch between the different rendering modes and even mix them on the same page. We're also working to enable new rendering capabilities like streaming rendering and progressive enhancement of page navigations and form posts to help your web UI become even faster and smoother. The idea is with Blazor United, you will have full flexibility within a single programming model to render your web UI in whatever the best way is possible. Now, I know that's a lot to digest. So to help show you what we mean, we've got Javier and Steve here to walk us through it. Javier and Steve, take it away. What do you got to show us?
Awesome. Thank you, Dan, for that great explanation. It's always great to see you explain these things. So I'll try to put some words into, or some facts into what Dan just showed you. Here we can see this Best For You Recipes app. This is an app that we initially built for the release of Blazor 3.1. And we've adapted. Can you hear me?
Yeah, I can hear you. Yeah, that's
okay. Sorry.
Memory lane, seeing this app from like way back in 3.1.
Yes.
It's funny how
those
long ago
those times doing CSS. Anyway, so for Blazor United, we have adapted this app to implement some of the features and things that we are trying to look at for .NET 8. So this initial version of the app is completely server-side rendered, just like MVC and Razor Pages. And you can do things like exploring recipes. You can see a particular recipe. And we can also do things like searching for recipes and so on. And if we look at the network, we see that all these are browser navigations. If we filter by document, that essentially covers navigations. So as I mentioned, this is just a server render app. Now, it is common for many apps to have large portions of the app that are dedicated to letting users consume content, okay? And these apps typically offer limited amount of interaction. So for example, in this case, filling a form and few things like that. As part of the work that we're doing in Blazor, we're trying to, as Dan mentioned, give you a way of enable these types of experiences and have much more control and flexibility on how your app renders and how your users interact with it. So with further ado, let me show you a bit how that is built. The first thing that I want to show you is this index view, which is the view that we were seeing before. Let me here. And you can see that this is a components page. It has the page attribute. It uses the inject attribute. It renders other components, defines parameters, and uses the lifecycle events that you're used to in Blazor Server and WebAssembly. Now, if we go to program.cs, there are a couple of new things that are interesting. This new add Blazor components that takes care of mapping all this, of registering all the services in BI that are required for rendering components server side. And then this new map Blazor components, which takes care of looking through all the components in your app that have a route attribute, registers them within routing, and takes care of rendering them server side.
So just to sink in a little bit, like what this means. So that app that you showed, even though that looks like the Blazor app that we showed back in .NET Core 3.1, it was actually functioning like completely differently. That was doing pure server-side rendering of those Blazor components and doing full page navigations as part of the UI. And that's this code is like setting that up, kind of like how you would set up like MVC controllers or
exactly.
But instead here we're pointing to components, like we're actually rendering that HTML from Blazor components.
Yeah. So the other thing that I want to show you is this main layout that we have here, which is the layout that all the pages are configured to use. And there are a couple of interesting things. It's again a component. It is rendering the entire document. So you are using components all the way through. You are not using MVC or Razor Pages or traditional Razor views to render the app. And the other part that is worth notice is that there are no scripts on the page because this is a fully server rendered app. So no JavaScript on the page.
Nice.
Now, there's another thing that I want to show you, which is that this model is not just restricted to consuming content. It also allows you to interact with content. And for that, if I go back to the app, I can click on a recipe, and I can, for example, here say, I'm just going to submit it. And then when I submit it, I can see that validation is triggering and all the things that we would expect on a server app to work. Now, I can also...
It's like a form post, like you're just doing a form post.
Yes. So if I now, for example, enter the data and I do a form and I add a comment, you'll see here that the comment was added. And when I look at the network, let me move this a bit up. I should have practiced this with the higher front settings. You'll see that here you can see that this is just sending form data. And you can see that the response is 302, which is a redirect, and the browser is just fetching the location from that redirect, receiving HTML as the response, and showing that in the screen. So this is essentially what is called the post get redirect pattern, and it's all done within Blazor Server. And you might be wondering how does that work? So for that, we can look at here, star rating reviews. So star rating reviews has this special edit context, and I will caution you all that a lot of the things that you're seeing here, potentially some of them might not ship in .NET 8, and some others might ship in a different way. And this is one that we're probably likely to evolve in the future. But what is happening is that when we register the pages, we map an endpoint for get, and we also map an endpoint for posts. And when a post happens, we render the app. And when you inject this special edit context within a component, we try to bind the form data to that edit context. And then within the uninitialize method of the component, we check if the edit context was modified and if it was valid. And if it's valid, we invoke the unsubmit callback. And if everything goes well, we just redirect. So this is the piece that does that post redirect get.
So that's kind of like your controller action, right? Or like your page handler in MVC. But this is also kind of different than how you would write this code usually in Blazor. Like in Blazor, you would usually have like an event handler on the like on valid submit or something like that would trigger when the form gets submitted when it's being handled client side. This is kind of a new way. Do we think this is how this will look? Like, what's our current thinking on like how this will actually look like when as a supported feature? Do you have any thoughts on that?
We have several options here. This is one of the ones that we explored. I also have explored another option where we give event handlers a name, and that essentially allows you to do a post and automatically trigger an event handler on the server. And again, the flow will be very similar as it is today. You render the app, you dispatch an event, and then that produces a response, and we send that response back. And when we start productionizing some of these things, I'm sure that we'll explore more design. So,
should we talk about which kinds of components should be expected to work in this sort of server rendered mode? Because it looks, from what you're doing here, like basically everything just works. But we don't have WebAssembly, and we don't have any connection to the server, and everything's being modeled through form posts. So could you comment on what sort of restrictions that means and whether components will just work or not?
So I'm not sure. Can you elaborate a bit on what you're thinking?
I assume like if you had like an on-click handler, right? Like on a component.
Yeah.
That's going to like, you want to click a button or tap on something and you want to trigger an event. In this world, I don't know how that would work. Like normally that would require at least some bit of JavaScript somewhere to handle that event. So presumably that level of interactivity isn't available here. You can do form posts, you can render the page, but you're not going to get all of the interactivity features of Blazor yet, at least.
Yes, absolutely. Like the way I would say it is in the initial version, you can think of it as we're going to be able to handle forms because that's essentially what you do in a server render app. We're not aiming at the very least right now to have a full and complete event system that you can use for server render apps. At that point, it would be something very similar to web forms. Yeah. But who knows? We're leaving options open. But for now, the only thing that we know is forms.
Looks like folks are asking about authentication and authorization in the chat. I assume at this point, like in this model, it would just be the normal cookie-based auth that we would normally use. Like this is server render. That's what we use for an MVC app. I think that we would.
You can do several things. You can I think it's too early to talk about that, but there are other options in this space here. So yeah, if we start talking about authentication and authorization, we'll have another 2 hours here,
Right. Yeah,
and we will not show
let's do
anything
the
else.
basic things first. Yes.
Okay, so let's actually move on to some more interesting things. So far we have seen a Blazor app being server rendered as a server app, just like Blazor Pages and MVC, and we call this passive rendering. And we call it passive rendering because the browser is essentially limited to consuming the content that comes from the server, in contrast to what we would call active rendering, which is where the code is running directly in the browser and is responsible for the rendering process, handling events, and performing updates on the UI. This is typically something that you'll see on single-page applications. Okay, now it is common for server-side render apps to offer an enhanced experience over the default browser experience without actually having or requiring you to switch to what we would call an active rendering mode, where the whole app, where essentially we allow you to provide an app-like experience without creating a single-page application. So examples of this mode are sites like GitHub and other sites that use things like turbolinks, hotwire, those types of things, where the app is still essentially server rendered, but through some JavaScript, they offer a more an enhanced experience over the default experience that the browser provides. So as I said, in this enhanced mode, all the content and interactions are server rendered. The app remains stateless, just like an MVC or Blazor Pages app. It's just JavaScript that makes the experience better. So in the context of Blazor, this means that we have another tier where we can improve the experience before we actually decide to render a component in Blazor Server or in Blazor WebAssembly. And that's the next thing that I'm going to show you. To do that, we're going to go back to our index page, and we are going to add an attribute here, which is streaming rendering. And then we're going to add our first piece of JavaScript to the page.
Well, just before you add that JavaScript, Javier, can I point out something that appears to be a bug in your application at the moment, which is whenever you submit that form, it was bouncing the user up to the top of the screen.
Yes, that's a good point. So that is because since we were, like, for example, in that case, since we are not where we're rendering on the server, essentially we lose the scroll position. But that's something that's one of the things that we're going to fix.
That's because it's a full post,
yes,
redirect, get, like, so the page completely reloads. And
then it's because it's loading a new document. So for example, just to be very clear, you see here that the network has nothing. If I click here, it's another document. If I go back here again, it's another document. It's the browser that is re-rendering that is causing that scroll position to be lost. So it's kind of jarring. Now, going back, we can go now to the main layout and add our script here. And what we're gonna use is, what we're gonna see is the first feature that we built, which is called streaming rendering. And streaming rendering allows you to deliver content to your users before the app has finished rendering, and deliver updates as part of the initial server response. And to simulate some of the slowness in producing the response, we have added a delay within our repository to say, hey, wait for 1 second. So this is how our database works. Now, if I go back to the app here, when I refresh, well, actually, let me close the network here. Let me go to the home. You'll see that for a second, it shows that loading recipes. And maybe we can also see it on a new tab. You see how the actual frame for the app and the shell comes back almost instantly. And then once the content is ready, the app all gets updated. This is all done server side without having to actually go and do a network request. So to make that point clear, I'm gonna just filter this for fetch, and you'll see again here that everything is loading, and the only thing that we sent back was the document.
So you browse to a page, that page needs to go to some database or do whatever, get some data before it can actually figure out all of the content that it wants to render. If you didn't do this streaming rendering trick, then the user just sits there and waits until all the work is done, the HTML gets sent down, and then they see the whole page all at once. In this world, they can see all the HTML that doesn't require the database request to complete. You just like you can see the frame, like the basic page layout, just the section with the recipes. Just has to wait until the database call completes, and so another like a second batch, a second delivery of HTML comes down to the client, and that's what that little bit of JavaScript now is handling, right? Like it's gonna
exactly, but it's all done as part of the same initial response. And there are a couple of important benefits that streaming rendering offers you. First of all, your app feels way more responsive because you are delivering the shell while the main content is still being processed, and instead of having to like stare at a blank screen until all the content is ready. I think we've all been in an experience where we've opened a web page and we've seen the thing spin for 5 seconds or 10 seconds and thought for ourselves, is this working? Is my network down? What's going on here? So this mode of operation allows you to keep your users on the page because they start seeing content, even if it's not the final content.
That reminds me of like, I don't know, like I've seen on Facebook or others where they have components that are kind of gray and it shows like the components here, we're just fetching the data for it, you know?
Yes, and that is also a common pattern in single page applications. The main difference here is that this is happening server side. It's not happening on the browser because
right, okay.
With single page applications, it's typical that you render a shell and then there are a bunch of skeletons on the page while things are loading and fetching data, and then you see the remainder of the content. Now,
perhaps we could clarify how this differs from the asynchronous rendering that already exists in Razor Pages, because in a sense it sort of feels a bit similar. Like you render some HTML and then you wait for some database query or whatever, and then you render some more. But it's not quite the same thing, right? Because with Razor Pages, it's rendering part of the HTML document and then it's just stopping. And so you don't have a finished document. And each part of the page has to wait for everything that's above it. Whereas with the streaming rendering you're showing here, it's able to emit the complete document outline and have any number of slots that are left to be filled in later. And then they can arrive in any order that they want, even multiple times potentially, before the response actually finishes.
Yep, that's exactly it. So the other benefit that I want to call out is that by being able to deliver the shell early, your browser is able to see all the links in the head, all the scripts that it needs to load, and it can get a head start downloading those resources and parsing them and processing them. And that is going to, in turn, actually reduce the time it takes for your app to fully load. So to drive this point home, I want to show you an experiment that I did before this meeting, where I created a couple of performance traces using the browser developer tools. And I will caution you that the traces that I'm going to show you are not representative of real life performance. And partly it's because of the way the network developer tools decide to simulate things like 3G and so on. But the comparison between the two should be relevant. So what I did is I took this same recipes app and I ported it to .NET 7 on WebAssembly. And then I measured the time to load for that app. And I measured the time to load for this app using Blazor United. And if I can go here, I can show you the trace. So this is the app ported in WebAssembly, and the first paint happens here at around 3.8 seconds.
And are you showing this, Javier? Is it?
Yeah, sorry. wrong screen. Okay, let me readjust this for a second. Thank you, Steve. I do not think I can move it further. Okay, so here, this is the first paint for the app, and it's happening. This is the WebAssembly app running on .NET 7, and it's happening at like 3.8 seconds in this simulated web fast 3G. And you can see if we look at the timeline, we can see where the actual page starts to do things. And it's probably up until a bit later that it renders the rest. Now, I believe we can also see, give me a second, I'm gonna move the window and I'll move it back so that I can find the other event that we were interested in, which was the time to first byte, or when the DOM content gets loaded. I'm trying to find it. Okay, I lost that one. So I'm instead going to go to the version with Blazor, and I'm gonna point out a couple of things. First, this is the Blazor United version. So we deliver the initial response very fast, and in 70 milliseconds, we already have the full document. We're firing the DOM content loaded event. And then the first contentful paint, I think it was called here. Where is it? I think it's sorry. Sorry, moving the window into a different thing broke all the things that I had carefully set up in my demo. Anyway, the main point is that the first paint essentially here happens much earlier, happens in 1.4 seconds versus the 3.8 seconds that you were seeing on the .NET 7 version. And the DOM content loaded event, which is when we deliver the initial payload, happens in 70 milliseconds versus 1 second in the other case. So overall, as we mentioned, streaming rendering gives you like a lot of performance improvements just because we're able to deliver the response before it is complete. So the enhancements that we have done are not limited to streaming rendering. Now that we have it as script to the page, there are a couple of other interesting things. So I am going to go to the main page. And the first thing that you're going to see is that whenever I navigate to a page, you can see no document being loaded. And that is because instead we are intercepting all the navigations. We're fetching the content, and we're applying the minimal difference to the actual page. So that's why I'm not sure if it's possible to appreciate it in the call, but you'll see that navigation feels way more smooth than in the traditional server render mode.
So it's enhanced navigation.
Yes.
Like, instead of a full page load, it's just like, it's kind of like a little bit of, I don't know, maybe this is, Steve, correct me if I got this analogy wrong, but like Blazor does this fancy diffing algorithm, right? Where it knows how to just update parts of the DOM. In this case, it's just updating the main body of the page and leaving sort of all the head stuff in place. So it doesn't have to like reload all that. So it still feels like a SPA style navigation, but it's still kind of getting most of the HTML from the server, just sort of the outer bits. Is that right?
Exactly. So your app is still stateless in the sense that like is server render, but it feels more like a single page application. And the other thing is that this is not limited to navigating through links. It's also enhancing forms. If we, for example, click on submit here, you'll see now that, as Steve mentioned in the beginning, we're not losing the scroll position. And this is because we are also intercepting the the form post here, and we are instead doing a fetch request and processing the response and applying the difference. So there are no more document loads every time that you click on a link or navigate. Yes, I was asking myself that same question: who would rate strawberries 2.5 stars?
Depends on the strawberry. Not all strawberries are made equal.
Fair enough. Fair enough.
But it's not. I want to make sure my analogy doesn't go too far, though. Like, this didn't actually, like, pinpoint update the DOM, just like the little validation messages in that page. It did still do the whole page. Is that right? But because it was inserting the content into the page, it was able to maintain the scroll position. Is that correct? Like, how much of the page is really blown away here? And
so,
how much
the server will send back the entire page, and we will I think in the prototype we're just like replacing the contents, but in the actual final version we plan to apply a div of the DOM tree and replace only the nodes that require changing.
Nice. So sometimes this is where we get some benefits from Blazor, right? Like, Blazor knows how to do that type of stuff, right?
Yeah.
As it happens, that's something I implemented in the prototype earlier today. So it does now fetch just the parts of the document that have changed and just patch the nodes that have changed. But I didn't merge it because I didn't want to screw up Javier's demo. So, but it is there.
Cool.
Perfect. I mean, I can say this will work whatever way I want, and then still we'll have to implement it. That's how it works. We all know it. Anyway, so going back, so far we have seen that we can write a server render app using components, and we can actually provide a spa-like experience or an improved user experience through streaming rendering and enhance navigation and form handling. However, there are times where you want to have rich interactivity in parts of your app, and those are the scenarios where Blazor WebAssembly and Blazor Server shine. And in no other way you can use Blazor Server components and Blazor WebAssembly inside of your server render components app to achieve that. So let me show you a bit how that works. I'm gonna close a bunch of stuff here. I'm gonna refresh. Now, if I click here on Submit Recipe, I'm gonna actually close the network tab for now. You'll see that we have this recipe editor, and we can try and add some data to it, and you'll see that it doesn't work. So it doesn't work because this is one of those places where we would want to have some more interactivity. Now,
those button clicks as opposed to a full form post type of use case.
Exactly. So we're gonna work on fixing that next. To do that, we're going to start by going to Submit Recipe here. And within Submit Recipe, we have this ingredient list editor. And to change how this ingredient list editor renders, we can add this attribute here called render mode equals server. So this will make the component render as a server component. Now I am going to run the app again. And this is going to take a bit to build.
Well, it is.
Laptop.
To make sure I understand, you're changing the render mode in the markup. Is that something you could also change at runtime?
We'll talk about that later.
Okay.
Let's not spill the beans.
John.
I'm just trying to, being an engaged viewer.
Okay, so there are a few things that I want to show you. I have here the network tab, and I'm going to filter this for WebSockets. And you can see that there are no WebSockets in the app whatsoever. Now, when I click on Submit Recipe,
no WebSockets here yet. No WebSockets here.
Exactly. When I click on Submit Recipe, you'll see that our familiar _Blazor WebSocket is there, meaning that we have created a server component, and if we try and go now and add an ingredient, this now works as you expect, and you can have the type of interactivity that you would expect. So we can add to X, for example, and we can reorder the items, we can like remove it, and so on. So one important thing to note, which is why I show you the network, is because as you saw when we were rendering the app on the server, we did not create a circuit ahead of time or anything. It was not up until we render a server component onto the page that we decided that we needed a circuit. So that allows you to have a pay-for-play model where if you're not using a server component, you're not paying for the circuit. And in the future, we also plan to tear down the circuit automatically once you stop using once you like remove the last server component. We might keep the circuit around for a few seconds in case that the next page renders also a server component so that we can reuse the circuit. But the idea is that you only pay for a circuit component as long as you are rendering. You only pay for a circuit as long as you're rendering a server component.
That's really nice. So that's better than what we have today with like the component tag helper, right? Like with the component tag helper, you can put a Blazor server component on a page, and then you add the like Blazor server script like for the app or whatever. But the circuit is then set up for the scope of where that script gets loaded, right? But with Blazor United, we're much more intelligent. We can sort of say like, oh, you've got a Blazor server component right here. Now I'll set up the circuit, which gives you much better scale out characteristics.
Exactly. And then in this demo, if we now try to like submit the recipe, we'll see that that doesn't work because we have not yet implemented it. So that's the next thing that we're going to fix. Instead of rendering the component here, we are going to render the entire page as a server component. And to do that, we're going to change a couple of things. We're going to remove this. Since this is now going to be a server component, we can use bind to bind the ingredients. And here we can add an attribute, component render mode, and we do web component render mode server. So with that, when I run the app,
Marvin on the stream is just asking if there are multiple server components, will there be multiple circuits? The answer is no. They will share them in this intelligent way.
Yes, sharing is caring. Like only one circuit for your server components. That way also they can talk to each other. Okay, so again, we're gonna do the same thing. We're gonna load here. There's no WebSocket. And now when I go to submit recipe, I see my WebSocket created. And if I do, for example, try to submit the recipe, you'll see that the validation gets triggered. And at this point, this is pretty much, since we have rendered this page as a server component, it is pretty much like a Blazor server app. We can, for example, add a new recipe. I'm going to add one for marble cake. I'm going to choose a picture for it. Yeah. And then this serves, I think, 8 people. And then you're going to see that we have all the rich things that you would expect on a Blazor server app, like parsing.
Maybe some marble, a few hundred grams of marble.
Ground marble dust. Or
yeah, exactly.
So do you folks know what a marble cake is?
Yes, we know.
Okay, so I'm going to add a bunch of ingredients. And as
really
we said,
is this your secret recipe, Javier? Is this like Javier's quite cooked, by the way, everyone. If you haven't seen Javier make paella, like it's a pretty.
Yeah, I was going to say, where's the paella recipe?
it is actually my own recipe that I'm developing.
Oh, wow. Okay.
I said, like, if we're going to do it for community stand-up, we should do it well.
Wow.
Okay, so I can now submit the recipe, and you'll see that the recipe got submitted. And then if I go back to the list of recipes, we can see that the recipe is there at the bottom.
5 stars. Everyone.
Yes,
5 stars.
exactly. Let's do that.
Cool. So that's mixing. Now we have a mix of the server-side rendering on the homepage. We have full interactivity with the Blazor Server page. We could do Blazor Server at the page level or at the component level, and it's smart about how it's managing the circuits. And it's still pre-rendered, right? Like that recipe editor page is still pre-rendering the content from the server, so it loads snappy, and then it transitions to Blazor Server.
Exactly. And as you can see, you can have some pages that are rendered Blazor Server, some pages that are just statically rendered pages, and they can both play with each other without
Nice.
without problems. So so far we had a Blazor Server for rendering interactive components. However, you all know where this is going to go now. This is not the only way to add interaction to your page. You can also use WebAssembly. So let's do that. Instead of here doing server, we're going to change this to WebAssembly, and we're going to do another trick, which is we're going to go to Blazor to our CS profile, and we're going to do Net7 browser. Okay, and I want to be very clear that this is for the prototype, and we have hacked a lot of MS Build to make this work. But the idea here is that your app is going to compile for the server and for the browser in a single project, and it's going to allow you to render components that are part of this project in WebAssembly automatically. So since we have changed where is it? Since we've changed our submit recipe page here, just making sure that we change this. Yes, we can now rerun the app.
So like normally
this is now going to.
Yeah, I was just going to say that normally your WebAssembly part of your app would be in a different project. Like you have like the client project, and if we're doing an ASP.NET Core hosted Blazor WebAssembly app, it might have a server project associated with it. So they build as like separate assemblies, right? Like the part that goes down to the browser is usually in its own project. In this united world, we're doing both from the same project.
Exactly. So with that in mind, I want to show you another thing. I'm just gonna like refresh the page here real quick, and I'm gonna show you that there are no DLLs being downloaded here. Okay, and this is again because it's the same model as the one that we had with Blazor Server. Up until you don't render a WebAssembly component, you're not gonna pay for the cost of downloading the runtime. And that makes a lot of sense because it is much more critical to deliver the page faster on the first interaction than it is on subsequent navigation. So if I now go ahead and click on Submit Recipe here, you'll see now that all the DLLs are being downloaded, and that this page is running using WebAssembly. So if I hit Submit, you'll see that validation gets triggered, and all the things that worked in server work also in WebAssembly.
So
the
download size there, like of course, was larger because this is during development. It's not published and trimmed and all those things. But if you were to publish this app, then the size of that Blazor WebAssembly page would also drop way down to like
exactly. It's like, and I don't know if we had to disable linking and other things for the prototype, but the idea is that the same experience that you have with two projects today, you would have with this single project. The interesting part is that since you're not necessarily downloading it to render the initial UI, it becomes less important the cost of having that download, because it's not critical to actually putting content on the screen, if that makes sense.
Now that TFM that you added, like technically Blazor WebAssembly apps today, they target the same target framework as like the server project, right? Like it's Net 7.0 in server and Net 7.0 in WebAssembly. So you could imagine just saying, well, use the same assembly, but I guess we want a separate target framework moniker because you might want different dependencies for the WebAssembly part of the app. And
Yes.
browsers do have their own API surface area. Like you might be using things that are very specific to a browser that you might want to set up for the Blazor WebAssembly part of the app. And that TFM allows us to create that ecosystem, right? Like a browser ecosystem for.
So if you're writing a library, you can have different implementations. One that is for WebAssembly and one that is for server. TFMs is the way that you achieve multiple assemblies as the output for a given project in .NET today. So that's the logical thing to do. However, I would also say again that this is something that we chose to do for this prototype and that might change or be presented in a different way as we develop this further.
And just to be clear, the Net 7 browser, that's just purely implementation details of the
project. It's
if we were to ship it, it would be Net 8.0
browser. We would expect the big part, the Net 8, 9, and so on, to match essentially. Okay, so we have done Blazor Server and we have done WebAssembly, but there is a caveat with this, which is we had to choose at compile time whether we wanted the thing to be server or WebAssembly. And the good news is that we don't actually have to, because we can instead choose this auto mode. And what the auto mode is going to do is it's going to automatically choose for you the best mode to render the app, to give you the fastest startup time that Blazor Server offers, and on the first visit, and then on subsequent visits, you're going to save on resources because it's going to download the runtime in the background, and the next time that the app navigates and renders that component, it's going to be able to just start it in WebAssembly. So you only use the circuit for the first visit. So now that we have auto here, we're going to run the app again. We're going to go here. I'm going to open the network tab. Now I'm going to clear all the site data. And then I'm going to refresh. So again, looking at the network here, no DLLs, no WebSockets. Now I am going to click on submit recipe here, and we're going to see that there's a Blazor circuit that got created because we did not have the runtime. We can see that we were also downloading the runtime in the background, so that is ready for the next time that we visit. I can now, again, go back to my page. I'm going to clean this. I'm going to do a page refresh here. No WebSockets, no WebAssembly. And when I click on Submit Recipe, no WebAssembly, but the app actually loaded using WebAssembly. And if I try and hit here, submit, the app is running on WebAssembly, so it's all the validations and all the things are working.
Nice. That's really nice. So it's sneaking WebAssembly down in the background on the first load, using Blazor Server initially, and then it can switch on the subsequent loads to use the Blazor WebAssembly runtime. So there's your runtime switch, John. There's a runtime change.
I'm sorry for I was foreshadowing. I was building.
That's fine. That's fine. Go ahead.
Well, so with this sort of thing where you have the auto magic mode, how do you debug if something's not working? You know what I mean? Is there maybe some way to tell or indicate? I don't know.
So the debugger should work in the same way that it works on a WebAssembly app. There's going to be a debugger running on WebAssembly, and there's going to be a debugger running on the .NET process. So if there is an exception and you are listening for exceptions or breaking on exceptions, it's going to trigger independent of where your code is. we might need to offer some experience where we kind of hint you at where your component is running. But it's something that you might potentially be able to infer from just looking at the call stack.
Okay.
So those are the things that as we work on making this vision production ready, like we'll have to figure out.
Wow.
Okay, so as we said, this is essentially allowing you to not be limited to choosing server or WebAssembly at compile time. You can choose it at runtime too, and that allows you to get a quick first load using Blazor Server for a quick start. And then on second, third visits, subsequent visits, you use WebAssembly and save on server resources.
Awesome. Nice.
Awesome.
Cool.
Finally, I have a secret demo that Dan and Steve have not seen that I'm going to show you.
It's like my birthday. Like, what is it?
Exactly. It's the Valentine's demo. And for that demo, I'm gonna switch to another app that we have in the repo for doing these things, because I did not have time to set it up on the actual example. So another important aspect of this type of architecture, where you render the app on the server and then start it up on the client, is data loading. And specifically, we want to avoid having to load the same data twice. First, when we render statically on the server, and then once again after the page becomes interactive. This is problematic since it doubles the number of requests that you do, for example, to your database, and it slows down the startup of the app. In general, in the single page application world, this is called hydration, because your app renders, and then when, like, it's the thing that John was saying about Facebook and the skeleton, your app starts rendering, and then it has to go and do a lot of fetch requests to the server to get all the data that it already got when it was pre-rendering. In contrast, what we want to do is we want to transfer the state from the server render app onto the client, so that when the client starts up, it does not have to like re-execute all the logic from the beginning. It can go and download the data again. It can instead just pick up from where it left off, essentially. And we already have support for doing this in Blazor Server and WebAssembly with pre-rendering, but we're further streamlining the support for this in .NET 8 to make it easier to transfer the state from the server to the client during the initial render. And for that, let me show you how we're doing it. If I run this app, I'm gonna go to fetch data, and we need to load fetch data directly, because if not, we will not be able to see it. So when I paste this, the first thing that we're gonna see is that we're gonna see the page loads, and then we're gonna see the loading text for a second. We're gonna see the data go away, loading show, and then the data show again. And that is because the first part is the pre-rendered content. Then the loading bit happens when the app renders interactively, and the new content arrives when it gets the content and finishes loading. And I think we've all dealt with this flash on Blazor applications.
Yeah.
Okay, so there goes the flash, and it's kind of undesirable. And there are ways to solve that today in Blazor WebAssembly, but we have a new way that we've been experimenting with, which makes this process more declarative. So to enable this, we are going to go to this weather forecast, and we're simply going to add this persisted attribute here. And obviously, as we mentioned all over this talk, everything here is subject to change and evolution as we start prototyping it. And then the other thing that we're going to do is, which I already did here, is to use the null coalescing assignment to essentially check if there is already data present or if we need to go and fetch it. What is going to happen now is that since we've added this persisted attribute to the property, whenever we finish rendering, we're going to capture this state and we're going to serialize it. And the next time that we render the app, we're automatically going to pick up that state and apply it to this property. So by the time we get to initialize the component, the data is already going to be there, and we're not going to have to do anything. That's a lot of words. So let's run the app again and see the impact that has. I'm going to copy this. I'm going to put it here. And now when I go and visit fetch data, you see that the data just loaded once. There's no loading. Your data is there. Your app is ready to use. On subsequent navigations, the data loads as you would expect, because you only want this to happen on the first navigation.
So this is the thing that you can do today with, like, there's that persist component state API that we provide that will, like, put
exactly
the state on the page, and you can then reload it. It's kind of manual how you set it up today, and imperative. This is like a declarative model for doing that, and it's
exactly
really fits great in the Blazor United world, because like everything's initially happening server side rendered, right? Even that interactive page, the recipe editor, like we're still pre-rendering that page and then transitioning to interactive, which means you have this state problem. Like state was set up initially for the pre-render, but now you have all these components that are doing the interactive rendering. How do you move the state over so you don't have to recreate it again? And that's what this really helps.
Exactly, and it's very common. So, for example, if you were also rendering the list as an interactive component, it would be something similar. You would have to go now again and fetch all the recipes from the server. So, this is all that I have for you today. And before I hand it off to Dan, let me recap on some of the things that we saw. So with Blazor, we're trying to make it so that you're able to render server, you're able to create server render apps using Blazor components all the way through. Your server render apps using Blazor will have an enhanced user experience via streaming rendering and enhanced navigation and form handling without requiring you to use Blazor Server or WebAssembly components. You'll be able to naturally render server and WebAssembly components inside the server render component application and choose how they should render, either from where you're using the component or from within the component itself. You won't have to pay the price of having an open WebSocket to the server or downloading the WebAssembly runtime into the browser until you render your first server or WebAssembly component in the app. You'll be able to render server and WebAssembly components simultaneously in the same document and interleave the two of them. I guess we didn't show that because it's not on the prototype, but that's something I think McKinnon might have shown in the past. But it's also, if he hasn't shown it, that's also something that we're going to work on, or that he's working on. And finally, you won't have to choose whether your component gets rendered on the server using or on the server or on WebAssembly at compile time. You will be able to choose how it renders at runtime to guarantee fast rendering on the first visit and resource savings on subsequent visits. And with that, Dan, it's all yours.
That's great. Thank you, Javier. That was pretty awesome. For that little bonus at the end was great. I know for people that saw Steve's video, and they're like, "Oh, I've seen these things before," and then they thought they could leave early. They thought they could leave, but they would have missed it. So good for
one more thing.
That is what I put it at the end, just for the true believers.
That's right. Here's another written summary of what Javier just went through, all the things we're working on in Blazor United. If you'd like to join us in this journey in working on these features, we'd love to have you help contribute, share your thoughts, share your ideas. aka.ms/blazor/united/discuss is an issue that we've set up on GitHub that's kind of like an epic issue for summarizing the whole effort. It links to all of the sub-issues that you can then look at for all those various features that Javier just talked about. So join us there. And yeah, we'd be happy to stick around and answer a few additional questions if there are any.
Well, there was one question on the chat which I thought would be a great one to start with, which was from Melissa, and it is, will this be available for preview 1?
Great question. Not yet. I mean, so the prototype bits are sitting in a branch right now in the ASP.NET Core repo. If you want to go build the repo yourself and play around with some of the bits that Javier just showed, and even some of the new stuff that Steve says he just is about to push, that's the Blazor-United branch on the ASP.NET Core repo. That's what's currently there. We don't expect any of those bits to show up in preview 1 of .NET 8 yet. We do expect to start seeing things around like server-side rendering of Blazor components to show up for preview 2. If you're new to our .NET 8 .NET release cadence, we ship once a year. Like, so .NET 8 is going to ship in November of this year, and we typically start shipping previews in February, and they're monthly. So February, March, April, you should expect a .NET 8 preview for each of those months. The first preview is expected to land here in February shortly, in about a week. And then next month in March is when you can expect to start seeing Blazor United features show up. We're going to see how far we get. Like, we hope to do all the things that we just showed you. We'll see how it works out. We don't know yet. Your feedback, your help, your ideas can help us refine what that work needs to look like, and so that we can land it as soon as possible.
Great. So we have some other questions that we could read off if we have time for those.
Let's take a couple. I know we shared a lot, and I know people were asking all sorts of questions, and then maybe we can take some of the chat to the GitHub issue afterwards.
Sure, sounds great. We do have a question about how Blazor Server and Blazor WASM will fit into this new model. Like what's the future of just using Blazor Server versus Blazor WASM?
Yes. Okay. So this, I mean, Steve and I have talked about this too as well. Like, well, could this just be Blazor? This is just what Blazor was meant to be, right? We could do that. The issue with the naming there is then when people want to refer to the way Blazor works now versus the way Blazor worked in the past, like how do they refer to that? You end up needing a name anyway. So I do think we'll end up needing some sort of clarifying term to help people know that when they're talking about this new unified model. But yeah, we do share that same sentiment, that this does feel like it's bringing all the Blazors, at least the web-based Blazors, together. And ideally, that could be just a single name. The original Blazor name, though, has history behind it. So yeah, naming is hard.
I would also add that even if we go to every possible logical extreme with this, and there's never any reason to use anything apart from this new model on the server, there'll still be use cases for WebAssembly as a standalone thing. Anyone who wants to create an offline application can't use anything that involves the server because it's not there when you're offline. So yeah, there's probably still going to be a separate Blazor WebAssembly project and concept forever.
Yeah, I think of this as very similar to like the whole .NET Framework, .NET Core situation, right? Like we really wanted the new .NET Core to be the .NET, and we actually rolled that out as the naming scheme for .NET. But sometimes you still need to be very clear, like when you're talking about the newer .NET platform versus .NET Framework, which had been around for over a decade, and so people still will refer to it regularly, I think, and at least informally, as .NET Core for that reason. I think we'll have that same issue with the Blazor naming unless we have something that people can use to clarify.
Yeah, I think another important thing to note is that this is also another choice that we're adding. But as Steve said, like Blazor WebAssembly is not going to go away. There are scenarios where like you can only do it with a pure WebAssembly app, and in similar cases, there are going to be many cases where you just want to have a server app that works like an app, and that's also something that is still going to work. So your Blazor server, your existing Blazor server apps are not going to go away, and everything that we do is only going to complement those. This new model is giving you more flexibility on the types of things that you can do, and allowing you to pay for things only when you need them, essentially. But it's totally fine if you're building, for example, a corporate app that is going to sit on your IIS to build and it's going to have 10 customers to build an entire server app, and that's great because you're going to have an app-like experience and are not going to have to worry about some of the concerns that you have to deal with this model too.
It's probably worth also mentioning that some people may be wondering, well, what does this mean for MVC and Razor pages? Like if Blazor's doing server-side rendering, what about my MVC apps? Like I have lots of those. Are those somehow getting going away? Like, and the answer, of course, is no. Like, we will continue to absolutely to support and maintain and improve MVC and Razor pages as a pure server-side rendering based model. This is not a replacement in any way of those technologies. We care deeply about backcompat in the .NET platform. And so when you upgrade to .NET 8, all your apps should continue to work, and we will continue to maintain those frameworks.
Perfect. So we also have another question about stream rendering in particular. There's a question about whether it's SEO friendly.
Yeah, it's a great question. So it depends how we implement it. The way that we've got it in the prototype is it simply assumes that it can use some JavaScript to update the page after it's been fully rendered. If a search engine crawler supports running JavaScript, then it should be able to see the final content like it does for single page applications. If you're concerned about crawler scenarios where they're not going to run any script, then you probably wouldn't want to have streaming rendering for those pages. And in fact, there's lots of situations where we've perhaps gone a little far in presenting streaming rendering as like this glorious thing that everyone wants in all cases. There are actually a lot of cases where you don't want it. And so it's likely that we'll make it an opt-in thing. So you would opt in places where the user is likely to be made to wait if you don't have it, and you're willing to accept that not all of your page can be viewed by people who don't have any script enabled.
Yeah.
One downside that comes to mind is the the content shift problem with streaming rendering. Like if you have a particular UI scenario where that update of the UI might create user experience problems, then you might not want to do it. That's why currently it's an opt-in model.
Yeah, definitely the content layout shift is a thing that you need to be watching for and designing for explicitly when you try to do things like this. The browser crawler thing, I would say that, and do not take my word for it, but I believe that Bing and Chrome both run your JavaScript, so they should be fine even if you have streaming rendering. But there might be other things that you can do potentially in the future, like disable those things when you know that the crawlers are visiting the page, because they have specific user agents that they use and things like that you could potentially detect to disable it. Like knowing about all those things is part of the work that we're doing in .NET 8 and figuring out all the hooks that we need to provide to enable those scenarios while still allowing you to use things like streaming rendering as much as possible are the things where we need to do work.
Cool. Anything else?
Yeah, we have a few more questions if we have time.
We have 25 starred questions, so the problem is picking
Yeah.
the right one. It's like,
Sorry.
McKinnon, I have no idea. You go for it.
Yeah, sure. Yeah, so we have a question about trimming. So if only some components are WASM rendered, does that mean we can trim down the .NET WASM files a bunch more?
Ooh, Javier, do you think you could explain how what we're thinking about in terms of compilation and how you would choose which bits of code are there for the server and which bits are there for WebAssembly?
Okay, so the way this works, or we're thinking it's going to work, is that you're gonna compile the project twice, and there's gonna be one version for WebAssembly and another version for the server. In general, the type will be present on both assemblies. You will just be able to do the typical things that you can do today in multi-targeting projects, where you have if-defs and things like that to have different implementations. We could potentially in the future automatically remove some components that are only present on the server, and that could theoretically allow us to trim the WebAssembly DLLs a bit more. But I do not think in general you're gonna get a big saving from doing that, unless it's a specific heavy component that you have that is bringing a big library or something like that, and you're only running that one on the server. You're not gonna get a big benefit from, you're not gonna trim the runtime much further just because you remove a component type, if that makes sense.
Yeah, so it's more about avoiding the wrong kinds of dependencies, right? So if you're
Yeah.
referencing Entity Framework for your server code, there's a pretty strong chance you don't want to reference Entity Framework on WebAssembly, because it's just not going to work out of the box. And even if you can make it work, it's quite big. So yeah, being able to control what gets included in your compilation is valuable. One thing we didn't talk about, but if you were very observant, you might have noticed in the demo, was there was a program.server.cs and a program.webassembly.cs. Sorry. So we kind of taken a bit of inspiration from Maui there, which has got a similar naming convention system for controlling which files are included in which compilation.
Yeah, in general, the inspiration that we take is precisely from Maui. So like I would, unless we see something different, I would expect us to see all the conventions that Maui follows in this project. So that is pretty familiar for you if you have developed a Blazor hybrid, or if you have developed a Maui app, you should feel right at home with the conventions here for Blazor United.
Since you do bring up Maui, both of you did, there were several questions about like, how does this impact Maui? How does this impact, Blazor hybrid and all that stuff? Have we covered that already, or is that?
We haven't said anything about Blazor hybrid and as part of the Blazor United effort. Blazor hybrid is about building native client applications, right? Like native mobile and desktop, using this hybrid pattern of web tech with native tech. For the Blazor United effort, we're focused on web, like building the experience for building web applications. It's much more about the MVC, Razor Pages, Blazor Server, Blazor WebAssembly spectrum of web UI technologies that we currently offer. So with this effort, it's not really involved with Blazor Hybrid at all. There are some other things we have been talking about for .NET 8 about how can we make doing Blazor Hybrid plus web easier and more approachable. Like if you want to have an app that does mobile, desktop, and web, you can absolutely set that up today by creating a .NET MAUI project with Blazor in it and creating a Blazor app for the web part and having like shared components in a Razor class library. It's very manual to set it up today. We have a doc that tells you how to do it, and you can piece all the right projects together. For .NET 8, we are thinking about what could we do to make that experience a little bit more seamless. We've even discussed, like, well, could we mash all of that into one project? That seems like has a whole bunch of questions that would then arise, like you're mixing potentially server and client concerns all in one project. Maybe that gets a little too crazy. Nothing committed there at this point for .NET 8. We may, for example, just do something simple like provide a template that makes it easier to set up all those scenarios. But yeah, Blazor United currently at least not involved with Blazor Hybrid. You should think of Blazor United as about web.
Yep.
Great. Well, this is not the end of the conversation. I know I can tell there's lots of questions we could probably still go into, but we also want to be respectful of people's time. The GitHub issue is there. So if you didn't get your question answered live right now, we will be on that GitHub issue watching people posting and discussing things about the various things that we're working on for .NET 8. So head over to that issue. So AKMS/Blazor/United/discuss. And that's where you can engage with us, anytime. We're always on GitHub and eager to hear what you have to say.
Awesome.
Awesome.
All right.
Great.
Wow, that was amazing. Yeah. And I'm sure we'll be having some follow-ups in the future as we, dig deeper into it. So.
Cool.
Yep.
Cool.
Yeah.
All right. Well, I guess I'll play the outro. Thanks, everybody.
Thank you. Bye-bye.
Thank you for attending.